Hi, welcome to ASMTower software tutorial videos. ASMTower is a software capable of designing monopoles, latticed towers, guide masts with struts, guide poles, poles with struts, or any combination thereof. In this example, we will learn how to verify the safety of an existing 55-metre tower according to TIA-222 code, and the unsafe members will be retrofitted. This is the single-line drawing for the tower. The tower consists of a tapered part followed by a fixed width part. The tapered part is 45 metres long, with the width of the bottom face 6 metres and the width of the upper face 1.5 metres. The length of the fixed width part is 10 metres. The tower has a square shape in the cross-section with 4 faces, having 2 ladders, one for climbing and the other for carrying transmission lines. This is a table of tower profiles. The 4th column of the table defines the main leg profile, followed by its grade in the next column. Here is the main diagonal profile, and it is followed by its grade. Here's the main horizontal profile, and is followed by its grade. We are going to define the geometry of the tower in the ASMTower software. But we need to add profiles from the database that will be used in this structure. Open Geometry Group. Open Selected Section dialog box. ASMTower has 2 databases, one for reading only and its content cannot be modified by the user, and the other for reading and writing, which can be modified in its content by the user. The read-only database contains most of the most common cross-sections and materials in the world, such as European, American, Canadian, and Chinese standards. While the second database contains what the user adds only and can modify any contents at any time. The read-write database is called user-define. We will add to the current project files from the read-only database. The first profile to be added is a 75x7 angle with a high tensile steel material called S355JR. In the material standard, specify the European standard EN 10025. In the material name, select S355JR. In the section type, select an equal angle. In the standard name, select the European standard EN 10056. In this list, select a 75x5 angle. Scroll down the list. Here's the angle. Click here to add the current selected section associated with the current selected material. Select an 80x6 angle and add it. Angle 90x6 and add it. Angle 90x7 and add it. Angle of 100x8 and add it. Angle 100x9 and add it. Angle 110x10 and add it. Angle 120x10 and add it. Angle 120x12 and add it. Now we will add all profiles used in diagonals and in redundant. Grade is S235JR. In the material name, select S235JR. This is the redundant table that displays the profiles used in redundant members. The smallest size of the angle used in this drawing is the 45x4 angle, followed by the 50x4 angle. Select and add a 45x4 angle. Angle 50x4 and add it. Here an angle of 60x4 and an angle of 65x4 are used. Select and add a 60x4 angle. Angle 65x4 and add it. Search for profiles that have not yet been added to the current project. Here, a 70 × 5 angle is used. Select and add angle 70 × 5. Almost all of the used profiles used in this tower are now added to the current tower project. Click OK to close the dialog box and save the entries. Open the latticed panel from the geometry group. Set the base elevation to 0. If the latticed panels are added above a pole, the base elevation should be equal to the height of the pole. If the latticed panels are above a building, set the base elevation here to 0 and enter the building height using the design code data dialog box. In each row, you can group every series of panels that have the same panel height, panel type, subdivision and slope together. All these panels have the same panel height. Set the top elevation to 45 meters. Set the panel type X. Set the subdivide to equal 1 where the panel contains only one secondary horizontal. Set the top width equal to 1.5 meters. The panel height is equal to 2.5 meters. Discard the crank ratio as it is required only when the panel type is cranked or portal. Set the base width to equal 6 meters. Set the number of legs to be equal 4 as the square tower has 4 faces and legs. In this fixed width part, there are 3 panels with a height of 1.667 meters each, one horizontal in each. The part starts at a height of 45 meters. Therefore, the top elevation at the end of the 3 panels equals 45 meters plus 3 times 1.667 meters equals 50 meters. But put it at 48.34 meters to see what mistake will happen. Set the panel type X. Set the subdivide to equal 1. Set the top width equal to 1.5 meters. Set the height of the panel equal to 1.67 meters. Ignore the crank ratio because it is not necessary for the panel with type X. Select the current row and on the keyboard click the Control button with C button to copy. Select a new row and on the keyboard click the Control button with the V button to paste it. Modify the upper elevation to be equal 55 meters. Modify subdivide to be equal to 0 since there is no secondary horizontal in these panels. The same for top width. The height of the panel itself. Click OK. From the geometry group, click the panel section to open its dialog box. Look back to the drawing. Let's start from the bottom up. The first 2 panels have the same main leg cross-section, the main diagonal cross-section and the secondary horizontal section. So, we can identify the 2 panels together. The height of these 2 panels is equal to 5 meters. Set the top elevation equal to 5 meters. Select a 120 × 12 angle with the S355JR grade for the main leg profile. Select a 70 × 5 angle with the S235JR grade for the main diagonal profile. Leave the main horizontal empty as there are no main horizontal. The symbol A is used for the secondary horizontal. This symbol is indicated by a 65 × 4 angle. Select a 65 × 4 angle with the S235JR grade for the secondary horizontal profile. Go to the next 2 panels that start from the elevation of 5 meters to the elevation of 10 meters. Set the top elevation equal to 10 meters. Set profile number 9 for the main leg as the previous panels. Set the profile number 14 for the main diagonal the same as the previous panels. Select a 60 × 4 angle for the secondary horizontal profile. Look back to the drawing. You may notice that each two panels have identical profiles. So we can define each two panel in the same input row. Each panel is 2.5 meters high. Therefore, the top elevation will be defined at multiples of 5 meters. Set the top elevation equal to 15 meters, followed by 20 meters. Select 120 times 10 angle for the main leg profile up to 15 meters. Select 110 times 10 angle up to 20 meters. Set the top elevation equal to 25 meters. Select 110 times 10 angle again. Set the top elevation equal to 30 meters. Select a 100 times 9 angle. Set the top elevation equal to 35 meters. Select a 100 times 8 angle. Set the top elevation equal to 40 meters. Select a 90 times 7 angle. Set the top elevation equal to 45 meters. Select a 90 times 6 angle. Search for the main diagonal profile. The last 5 meters from the top of the tower have a 45 times 4 angle to the main diagonal. Select a 45 times 4 angle. Select a 50 times 4 angle. Here the angle is 60 times 4. The 60 times 4 angle is number 12 in the list. Select a 60 times 4 angle. You can select an angle from the list or directly type your profile number. Set it at 12 like the previous. You can select the profile from the list or type its number here in the list directly. The 65 times 4 angle is used for 6 panels, that means 3 rows. Select a 65 times 4 angle that is number 13 in the list. Type 13 twice. We have now defined the profiles for the main leg and main diagonals of 45 meters below. Start defining profiles for the secondary horizontal. In these two panels, the secondary horizontal contains the symbol C, which means the angle 50 times 4 with the grade of S235JR. The following two panels have the symbol D for the secondary horizontal. The notation symbol D means the angle 45 times 5. Select a 45 times 4 angle. However, the list does not have an angle of this size. Therefore, we need to add it first in the selected section. Click OK. From the Geometry group, reopen the Selected Section dialog. Select this row and copy its content by clicking a keyboard Control button in addition to C button. Select a cell in a new row. To paste, click the Control button on the keyboard in addition to the V button. Change the section name to the 45 times 5 angle. Click OK. From the Geometry group, Lat Panel group, reopen the Panel Section dialog box. Open the list again and select the 45 times 5 angle. Note that the profile number has been added to the old value. This is because the lattice panel may contain a series of secondary horizontal members with different profile size and material. Therefore, you can specify a series of profiles that will be assigned to a series of secondary horizontal members. Let's clear the cell value. Select a 45 times 5 angle. The next panels up to the end of the tapered part have a notation symbol E, which means the angle of 45 times 4 with the grade of S235JR. Select a 45 times 4 angle. This angle is the number 10 in the profile list. Type its number in the list here that equals 10. Type 10 again for all of the following rows. We have just selected all profiles in the tapered 45-metre section and will identify profiles for the top 10 metres remaining. The first 3 panels have the same profile for the main legs, the main diagonals and the secondary horizontal members. These 3 panels have a total height equal to 3 times 1.67 metres equals 5 metres. Therefore, the top elevation of these 3 panels is equal to 50 metres. The following 3 panels up to 55 metres have the same profiles. Set the 80 times 6 angle in the main leg up to an elevation of 50 metres. Set the 75 times 5 angle in the main leg to the end of the tower. The main diagonal size is 45 times 4 angle in all 6 panels. Select a 45 times 4 angle. Type its number in the list here that equals 10. The 45 times 4 angle is the secondary horizontal profile from elevation 45 metres to elevation 50 metres. Copy and paste the previous value here. The last 3 panels have no secondary horizontal, so set it equal to 0. We have left cells for all secondary diagonals blank because all latticed panels do not contain secondary diagonals. Click OK. Select Design Drawing on the bottom tab to review the single-line drawing of the tower. The tower is drawn here. Click the plus button to zoom in the graphic. You can see a missing horizontal member here, as well as here at the bend of the main leg. Return to the drawing of the existing tower where the main horizontal is located on these 2 levels. The upper main horizontal has a profile of the angle of 50 times 4. Reopen the panel section dialog. In the main horizontal, select a 50 times 4 angle. Click OK. Click Update to refresh the drawing. The main horizontal is added to the 3 panels where they are grouped together in the last row. We want to edit it to allow it to be added only to the last panel. Set the main horizontal profile to 0 to remove what was just defined. Instead of the main horizontal column, use the top panel horizontal column and select a 50 times 4 angle. Click OK. Click Update to refresh the drawing. Now you can see that the horizontal member is only for the last panel. Do this again for the row at the top elevation equal to 45 metres. Type here the profile number in the list that equals 10. Click OK. Click Update to refresh the drawing. The second horizontal is drawn in its correct position. You can see that only 2 panels after an elevation of 45 metres have a secondary horizontal, but we have defined a profile in the secondary horizontal for all these 3 panels. We need to review the subdivide definition for this panel in the Panel Geometry dialog box. Open the Panel Geometry dialog box. We have identified here that the panels are subdivided by 1 subdivision up to a height of 48.34 metres. The top elevation of the 3rd panel with a secondary horizontal was 45 metres plus 3 times 1.667 metres equals 50 metres. Adjust the top elevation to be equal to 50 metres. Click OK. Click Update to refresh the drawing. Now, secondary bracing has been added to the 3rd panel. This drawing is produced by ASMTower, and you need to review all the tower profiles in it with the existing tower drawing to ensure that all tower entries are corrected. Now we have finished identifying the members of the tower. Return to the 3D view on the bottom tab. Click the left mouse button while moving the mouse to move the tower. Rotate the mouse scroll to zoom in and out. You can see that the main horizontal and secondary horizontal become identical to the current tower drawing. Click the Save button to save the project. Type a name for the project file. Click Save. Click the left mouse button while moving the mouse to move the tower.